Now, this is a different way of learning this, so pay attention. But when I first started teaching Algebra 1, I did it what I would call the normal mathematical way. Then after seeing the looks on the faces of my students, I changed it up a little bit. Do y'all remember me talking last year about the big ugly? Okay, good, the big ugly. Okay, so we're going to talk about, it's like intruder alert. Y'all know what intruder alert is. Well, y'all are going to know what the big ugly is. Okay, scientific notation. A number is written in scientific notation when it is expressed as a product. What's a product? There you go, and I'm going to put X. That doesn't mean like X and Y and everything, that's just X. Like times, multiply. See, you already got one thing right. Good job. In the form A times 10n. I'm going to circle that. That's what scientific notation looks like. Now, what's really important, and I'm going to put a colon here, is this. A, and I'm skipping a line because this is really important. A is greater than or equal to 1, but it's also less than 10. In other words, A is the number is between 1 and 10. And I'm going to explain that to y'all. But this is huge. I'm circling it and putting a star. But this is huge too. And I'm not going to leave it out. I put an arrow in a star. These things are important. This right here is how scientific notation is written. And I'm going to show y'all that. You don't have to memorize it because most of you have seen this before. You're probably like, well, there's an A and an N. As soon as I write it down, you're like, oh, yeah, I got it. But this right here, the reason I have stars all around it is because whatever the number is right here, and guys, I cannot express this enough. Whatever the number is here, it must be between 1 and 10. It can't be 11. It can't be 10.1. The number must be between 1 and 10. It can be 1, but it can't be 10. It's got to be between 1 and 10. This right here is the most important thing. Yes? That's a multiplication symbol. No, that's a good question. Don't be embarrassed. By the way, I think you left a fingernail in Spanish class. Okay. So anyway, this is not like X, the letter X, like when you're graphing a line. This means times. Okay? Okay? That's why when I do X's, I always do them kind of like fancy like that. Okay. Anyway, does everyone have this down? You got it, Valeria? People in the back? Ariel, do you have it? Okay, good. So, I'm just going to jump in and start giving you examples. Let's say they want to put this number into scientific notation. So they gave you that number right there and said, put this in scientific notation. Okay, well, hold on. First of all, do you have a question yet? Okay, first of all, I need everyone's attention. Is this number between 1 and 10?
No.
Absolutely not. Ariel, do you see that? It is not between 1 and 10. So what we've got to do is make it between 1 and 10. So we're going to put an imaginary decimal right here. And I'm going to move the decimal so many places until I get it to where the number is between 1 and 10. And what I got is 2.95. Is that number between 1 and 10? Yeah. If I had moved the decimal right here, that would have been 29.5. That is definitely not between 1 and 10. Typically, in fact, where should the decimal always be? Right behind that first number. It's always going to be right behind that first number. Y'all see that? That's going to make it between 1 and 10. Okay, how many places did I move this?
4.
That's right. 4 places left. So the rest of the scientific notation, remember, it's a times 10 to whatever power, right? So then I'm going to write 2.95 times 10 to the 4th power. And there's my answer. It's always 10 to whatever power. Good question. Miranda asks, is it always 10 to some power? Yep, always 10 to some power.
Is that a multiplication or
That's multiplication. Notice 2.95, and you need to write this down because you will be probably referring back to notes, is between 1 and 10. And we moved the 4 places to the left, so that 4 we put right there as our exponent. Something else I want to draw your attention to. Some of you are sitting there going, oh, that's it? Okay, I got this. Just wait. Notice also that it's a positive 4. Notice that the 4 is positive. You need to take note of that. Yes, you will be dealing with some negatives there. And those are okay. We don't like them, but they're okay. So you're going to sometimes have a positive and sometimes you're going to have a negative. And I'm going to explain to you why. Basically, 10 to the 4th power. What does that really mean?
400?
That's 10 times 4.
Right?
What's
That's
that?
10,000.
That's 10 times 10 times 10 times 10, correct?
10,000.
Whoops. Isn't that what that means?
So 1,000. It's 10,000.
Oh dear.
It's 10,000. Right?
Which is it?
10,000.
Is he correct?
Yes.
I have no idea.
What?
Okay.
If I were to take that and multiply it by this, would I get this?
Yeah, you
Wait.
will. I don't know.
Yeah, you would.
How many zeros?
4.
One, look, 1, 2, 3, 4. It would give you the same thing. That's what this is.
What about I thought scientific notation was a little box with the thingy.
No box and
That's
thingy.
square root.
Oh, okay, never mind.
Yes.
Does it always have to be, like, the decimals have to be after the first number?
Yes. For it to be official scientific notation, it's going to be here because it's got to be between 1 and 10. And in fact, your book, tests, and quizzes, they may give you something and say, is this in scientific notation? You may think it is, and it's not. They may have the decimal right here, or they may have the decimal right before the 2, and all you've got to do is move it. And then you've got to adjust the exponent, which is what we're going to do in just a second. All right, so more notes. When putting a number into scientific notation, if you move decimal left, the exponent is positive. Now this can be misleading, and so I'm going to teach you something different in just a minute. Some of you are going to probably get this. Some of you it's going to be a little much. I get confused. As your teacher, I always get confused. And I'm going to show you, you know how like figuring out text, figuring out intruder alert, I always give you my own little personal spin on it. Wait till y'all see my personal spin on scientific notation. The calculus students still remember. If you move, and if we're putting it into notation, if you move decimal right, the exponent is negative. And that's, again, I'm copying this kind of from book, but just bear with me on this one, okay? Don't stick to this right now, okay? Don't hold on to it before I start showing you my little spin, because then you may get confused. And then I'm going to give you my little spin. Here we go. And wait till y'all are done with this. All right, here's Mrs. Rogers. Big star. Normally, whole number has positive exponent when working with it, okay? Like adding, in fact, I'm going to say right here, adding. Okay? So normally a whole number has positive, or you're adding exponents, and big, ugly decimal number has negative or subtracting exponents. And I'm going to demonstrate a big ugly for y'all in just a minute. I don't know why, but ever since I started talking about big ugly and whole numbers, my students just get it. If you don't think too much into it, they get it.
The key is not to overthink it.
Yeah, no, with this, definitely. I'm telling you, I have had lots of special classes over the years. And they have been able to handle big ugly for some reason better than any other mathematical explanation. And no offense to Mr. B, he will come in here and give you the logistic, real explanation on this stuff in mathematical lingo and everything. But I guarantee you guys are going to learn big ugly way before you understand what he's saying. In fact, I'm telling you, even on the PSAT, the kids are laughing. Ms. Rogers saw big ugly. I figured you would. Are y'all ready? I'm going to give you an example of a big ugly. Here we go. Here's big ugly. Now I'm going to have to count. Okay. Let's put that into scientific notation. That, my friends, is big ugly.
Is that 7?
There's 7 zeros there. 7 zeros in between. From this decimal to the 4, there are 7 zeros. That is big ugly.
What kind of number is that?
A big ugly one. Get it? Seriously. Chap is not amused yet. Is that big and ugly?
Can it happen with non-zero? Like if you just have like a point and then like 1, 2?
We'll talk about that.
Okay.
Okay. Big ugly. Now, is this, and we need to put it into scientific notation, right? Is this number in scientific notation? In other words, is this between 1 and 10? So we need to do that. We do it by moving the decimal right this time. 1, 2, 3, 4, 5, 6, 7, 8 places to put it between, like New said. Is it always going to be between that first number? Yes, we moved 8 places right. Keyword. So this is going to take everything that I wrote here and make sense. So if we move it 8 places to the right, and it's big ugly, what did I say right here? Deals with negative exponents. That's 4.3 times 10 to the
Negative 8 power.
perfect, to the negative 8 power. Oh, yes, you can. Scientific notation. That's when we're doing all the other stuff. But in scientific notation, yes, that's why I don't like this chapter or exponents.
Do you have to have it or?
Now, this number, is this number between 1 and 10?
Yes.
So this is correct. Now, look at this. Look at this one. Did we start out with big ugly?
No.
No, we didn't. And to put in scientific notation, which direction did we move the decimal? So we got a positive exponent. So this time, we moved the decimal right, and we got a negative exponent. That is what you have to memorize. And my students have trouble with that sometimes. When is it positive? When are you adding? Because we're about to do more stuff. This is the basics. And then once we start doing multiplication, division, adding, and subtracting of this stuff, they forget. So I tell them, to me, this is big and ugly. And I don't like negative exponents. Boom. That's the correlation. You're like, I don't like subtracting either. It's just a personal thing. So big, ugly, negative, or in a little bit we may be subtracting. Here, normal number, which there could be a decimal in there, but we're not talking about this, and we're moving the decimal left. So it's going to be positive, or we're adding. This is the rule. These are the rules. But it's hard to remember, when is it positive, when is it negative, when are you adding, when are you subtracting. Big, ugly, you're subtracting or you have negative. Normal number, you're adding or you have positive. Okay, big, ugly, negative, subtracting. Okay, all right. Now, let's do another example. What if they give you the scientific notation? This is where that's confusing, that other rule. And they want you to put it into regular number. Now, if you memorized this over here, keep in mind this is putting it into scientific notation. If you move the decimal left, if you move the decimal right, okay? But that's different here. It's already in scientific notation. They want you to take it out. So guys, are y'all ready for this? Is that a positive or negative exponent?
Positive.
So then my end number, is it going to be big ugly or is it going to be a normal looking number?
Normal.
right? Because positive gives you a normal number, see? Positive exponent, normal number. Negative exponent, big ugly. Or you can say, well, I need to memorize this and then do the reverse. Or you can memorize normal number, positive, big ugly, negative. So if this is positive, is my end number going to be big ugly or normal?
Normal is going to be big.
So then I'm going to rewrite my 2.1 here. And I'm moving the decimal. If I move it to the, if I move it to the left, I'm making it big ugly. If I move it to the right 5 times, 1, 2, 3, 4, 5. Put in your zeros where those little loops are. And your answer is 210,000. Very good. See? Positive exponent means your final answer is going to be a normal looking number. If this was negative, we'd be moving the decimal in another direction to make it big ugly. So positive exponent means, and I'm putting this in quotes, just because it's not always going to be, but it's not going to be big ugly. Whole number answer. Not big ugly. And we moved it 5 places right. So far, over what I have shown y'all, do y'all have any questions? Good. Make sure you're writing good notes, because I'm going to tell you, when you start doing this, you're going to forget which way do I move that decimal. It's easy to forget, especially in the afternoons when you're tired. But if you have good notes and you remember big ugly, you'll be fine. All right, so let me give you another example. Does everyone have the notes? Valeria, you got all that?
Yes.
Okay, good. Ariel, you good back there? All right. Keith? All right. Matt, Miranda, you good? Okay. What if I have this? This is already in scientific notation, and they want you to put it in, back into its normal number. What is that number?
Oh, that's big ugly.
Okay, very good. Notice, what's your exponent here? Is it positive or negative, Valeria?
Negative.
So then, all you got to remember is, negative exponent, big ugly. So we're going to be moving the decimal. Who said left? Okay, good. So we're going to be moving it to the left to make it big ugly. So 1, 2, 3, 4, 5. Oops, I'm off the screen. 6. And you put zeros in those loops. So then your answer is point, and there's 5 zeros. 1, 2, 3, 4, 5, 6, 8.
68 8/millionths.
So there's your answer if you have a negative exponent. That's big ugly. Negative exponent. Oh no, we haven't even began multiplying and dividing. So do we understand how to move the decimal and stuff? Like I said, it's like, okay, I'm getting it. But it does get confusing, and you can get frustrated. So please make sure you keep your notes with you when you're doing your work, and just kind of slow and steady, attention to detail. Make sure you're moving it in the right directions. Oh, and I forgot to write 6 places left. So you're moving it basically the opposite of if you were putting it into scientific notation. Again, that's hard sometimes, bless you, for my students to remember. That's why I invented Big Ugly. Now, Miranda wanted to learn this, so let's get started. Multiplication and division with scientific notation. Not scary. Not scary at all. If you guys got this stuff, you're going to be fine. But pay very close attention and take good notes. Multiplication and division with scientific notation. Are y'all ready? Good? All right, here we go. Keith, you awake? Once I show you this, you're like, oh, okay. 7.5 times 10 to the negative 5 times 2 times 10 to the third power. Okay. Again, make sure you've got good notes. If you can't see, let me know. That's a 3 up there. So you see we have two things in scientific notation, right? And we're multiplying. Guess what you're going to do? You're going to group. So watch this. Are y'all ready? I'm going to combine. Notice, I'm going to combine like terms, sort of. I'm combining my two normal numbers, and then I'm going to combine the tens and their exponents. So watch this. 7.5 times 2, and the next parentheses, 10 to the negative 5 power times 10 to the third power. So look what I did. I took the two numbers at the beginning and put them in a parenthesis, and I'm still multiplying. See, that's multiplying, multiplying. And in this group, I have the tens and the exponents. Y'all see that?
Is there, for the answer, will it only be 1?
No, you're going to just wait. Who can tell me what 7.5 times 2 is, Franz?
15.
15 times, because we're multiplying. Now, let's see, Miranda. Look here. Are the bases the same? So if the bases are the same and we're multiplying, what do we do to the exponents? That's right. Valeria, do you see that?
Yes, ma'am.
So if the bases are the same and we're multiplying, we're going to add the exponents. So then it's times 10 to the what, Miranda? Yep, to the negative 2. Y'all think we're done? So question, Ariel, is number between 1 and 10? It's not. Oh my. Chat, what shall we do? It's 15. It's over 10.
You move it left.
Okay. Oh, now we're moving it left. We're going to put a pretend decimal here and move it left. So we moved it left. But if you're like, man, does that mean it's positive, negative, what? Well, let me ask you, chat. Was this a big, ugly number, or was this a normal number? So then are we subtracting or adding the exponent? Is it going to be a negative or positive? Is it, if it's a normal?
Add it.
Ah. So then it's 10. See, here's our new number because we moved the decimal here. So it's negative 2 plus 1. Very good. Because we moved it left. And if you remember, putting a number into scientific notation, if you move the decimal left, the exponent is positive, or we're adding basically. So we moved it left one place, and it's not big ugly. So if we moved it left one place, we're adding 1. So then, Chap, what's -2 plus 1?
-1.
So 1.5 times 10 to the -1. There's our final answer. You add 1 if it's not big ugly, or you're just moving it left. If we moved it left twice, we would add 2.
If you moved it right, would you subtract?
Bingo. If you moved it right, and I'm going to show you an example. If we move it right, you subtract. Is it kind of making sense?
Mm-hmm.
Does everyone have this down? Do you have it down? Let's do another. What if I have this 1.2 times 10 to the -4 with a 2 on the outside? Sophia, what's the rule with the exponent on the outside? Apply it to everything. So we're going to apply it to this and the -4. So this becomes 1.2 squared times 10 to the what, Sophia? -8. Very good. Does everyone see that? Does anyone have questions as to where we got this? Okay, good. So, let's see. Keith, what is 1.2 squared? Huh? Well, what's 2 times 2? Keith, 2 times 1? A 0. What's 1 times 2? 1 times 1? I get 144. How many total places in the problem?
2.
So then we go 2 places here. So then I have 1.44 times 10 to the -8. Now, question. Ariel, is number between 1 and 10? Yes. Guess what? We're done. That's our answer. As long as your answer is between, your number is between 1 and 10, you're good to go. If it's not like this problem, like this problem right here, where it was at 15, then you got to fix it. How's that? Y'all figured out now multiplication? Okay, good. Let's do some division. Example. 2.4 times 10 to the 7th power divided by 6 times 10 to the 2nd power. Okay, unlike multiplication where all you're doing is grouping basically and solving, which is fairly easy, this one you're going to set it up differently. Y'all ready? You're going to set it up on top of each other. I'm going to take this one, 2.4 times 10 to the 7th power, put a fraction bar, and then put the other one directly underneath. I'm going to save y'all some time. Is everyone watching? 2.4 divided by 6. Anyone want to guess? Raise their hand. Or know it? Oh, the wheels are turning. Chat?
0.4.
Correct. 0.4. Now, times. Guys, look right here. This is a 7, by the way. We're dividing, right?
So you subtract.
Miranda, if we're dividing and the bases are the same, what do we do to the exponents? Miranda? That's right. So we're going to subtract 7 minus 2. What do you get, Miranda? Okay, so it's 0.4 times 10 to the 5th power. Question, Valeria, is this number between 1 and 10?
No.
No. Oh dear. So like New was saying, well, huh?
Move it to the right.
This time, okay, Valeria's right. This number is not between 1 and 10. We're moving it this time to the right once. So if we're moving it to the right, are we going to be adding or subtracting?
Subtracting.
Bingo. So we're going to be subtracting. So we end up with 4 times 10 to the 5 minus 1 because we're going to the right. Remember the big ugly, go to the right, negative, blah, blah, blah. So then Valeria is correct. We have 4 times 10 to the 4th power. There you go. So don't forget, we're subtracting 1 because you could either say big ugly or, whoops, we're moving right. Any questions? Yes, ma'am.
This isn't a question that I do not, but it looks like it's about one.
Okay, but you're responsible for everything you miss. All right.
I understand what it's
Okay. Does everyone have this down? Open up your books to page 341. Number 1. It says express each number in scientific notation. So they gave us this.
Oh.
Is this big ugly? No. Do you see that? Well, I mean, kind of is, but it's a big old whole number, right?
It's not really ugly, it's a number.
Exactly. So, is this number between 1 and 10? No. So, Sophia, what do I need to do? That's right. 1, 2, 3, 4, 5, 6, 7, 8. We got to move it there. So 8 places left. So what's my answer, Sophia? To what? To the 8th power. Understand? Okay, let's look at 3. Morgan, 0.0000052. Morgan, is that big ugly?
Yep.
So what do I need to do?
You gotta move the decimal point 5 times to the right. Until you get to 5.2. And then it's 5.2 times 10 negative 5.
Perfect. Big ugly, moving it right, negative 5. Now look at number 5. 13.6 times 10 to the 7th power. Keith, is this number between 1 and 10? What do I need to do? So I'm moving it one place left. So am I going to add an exponent or subtract it? That's right. So then it's, what's your exponent?
8.
That's right. It's going to be 7 plus 1, which is 8. Any questions? Y'all have it? Got it? Sophia, do you have it? Okay. I just have a couple more. Let's see. That was 5. Okay, the next one. Express each number in standard notation. That's like the same thing. Okay, so look at 11. They gave us 1.53 times 10 to the negative 4. Okay, that's a negative exponent. So, new. Is your final answer going to be big ugly or normal? It's going to be big ugly. So how many places do I move the decimal in which direction? That's right. We're going to move it to the left. 1, 2, 3, 4 places. And you put zeros in those hoops. And so you get 0.000153. Big ugly. Any questions? 13. We're multiplying. 2 times 10 to the 2nd power times 3 times 10 to the 5th power. Franz,
Yes.
what am I doing?
Basically like combining, grouping.
Grouping. Good. Miranda, what am I grouping? He's right. And your 10 with the exponents. Very good. So I have 2 times 3 times 10 to the 2nd power times 10 to the 5th power. Valeria, what is 2 times 3?
6.
So I have 6 times 10. And Valeria, the bases are the same. What?
7.
Perfecto. We add. There you go. Oh, I forgot. Franz, is this number between 1 and 10?
Yes, it is.
Yes, it is. Number is between 1 and 10.
Well, it's kind of easy now because you were so
Now I have one more, and I'm setting you free. 17. 4 times 10 to the 11th divided by 8 times 10 to the 4th. We're going to set it up on top of each other with the fraction bar. What's 4 divided by 8?
0.5. Because 4, it's half of it.
No fractions. Decimals. 4 divided by 8 is a half. If you reduced that and saw that it was a half, you just need to turn that into a decimal. So 0.5 times, bases are the same, so what do I do here with the exponents? Subtract. 11 minus 4. And I get 0.5 times 10 to the 7th. Is this number between 1 and 10? Sophia, what do I do? So if I'm moving it to the right, do I add an exponent or subtract it? That's right, we're going to subtract it. So then I have 5 times 10 to the 6th power. Any questions? Okay, now watch what I'm telling you to do. Page 341 to 343. I may not even do that much. Yeah, forget 343. 341, you're going to do numbers 2, 4, and you got to be specific here. 14, that's 14 by the way. 16, 18, 24, and that's it.
That's
Due Tuesday.
really.
Because tomorrow we do adding and subtracting.
If we do something wrong, that's a lot of points.
Right, but you could get it done. Quiz Thursday, IXL due, I said Friday, right? It's still due Friday. That's not me.